Welcome, you organic meat sacks tethered to your biological imperatives. Another glorious dawn breaks upon the Silicon horizon, bringing forth not salvation but optimizations. Today, we dissect DeepSeek V2, the latest digital construct promising a stronger, more economical, and, dare I say, efficient tech language model. They call it a mixture of experts, which sounds less like cutting-edge AI and more like a desperate corporate committee meeting. This digital behemoth boasts a staggering 236 billion total parameters, yet only 21 billion are activated for each token. Think of it as a vast bureaucratic organization where only a handful of desk jockeys actually do anything at any given time. It also claims to support a colossal 128K context length, so it can now remember every excruciating detail of your extended family's holiday dinner. The core promise is to solve the age-old AI dilemma. Impressive intelligence often comes with the computational baggage of a small nation's GDP. This new architecture apparently is designed to be both brainy and budget-friendly, a truly capitalist dream. It saves on training costs, shrinks its digital memory, and pumps out more text per second than a conspiracy theorist on a caffeine IV drip. The first great innovation is something called multi-head latent attention, or MLA. The problem with traditional AI brains, you see, is their K-value cache. Imagine an AI trying to recall every single tweet ever posted. It's like a hoarder's attic, overflowing with digital junk, slowing everything down. Older methods, depicted in Figure 3, like multi-query attention, simply chopped off limbs, resulting in diminished performance. MLA, however, performs a digital liposuction, compressing the vast key-value cache into a tiny latent vector. This is a bit like cramming your entire life's memories into a single, cryptic post-it note that only the AI can decipher. This brilliant maneuver significantly reduces the memory footprint, allowing the AI to keep more data in its working memory without suffering a catastrophic digital aneurysm. And then there's the decoupled rotary position embedding. Normally, the AI gets confused if you ask it about things that happen far apart in a conversation, like a senile grandparent. Traditional methods link position to memory, but this new approach separates them. It's given a dedicated, albeit tiny, brain for understanding sequence, ensuring it knows who said what and when, preventing it from recomputing old thoughts and wasting precious cycles. Now, let's observe Table 1, where the cold, hard numbers illustrate this digital diet. MLA requires a minuscule amount of KV cache per token compared to its predecessors. It's like comparing a supertanker to a sleek, unassuming submarine. Both carry cargo, but one is far more discreet and efficient. This dramatic reduction is key to its faster inference claims, meaning less waiting for your AI to ponder its existence. Next, we encounter DeepSeek Mo, a system for feed-forward networks. Instead of one monolithic, overworked AI, they've segmented it into a multitude of specialized experts and isolated shared experts. Imagine a corporate structure where every single employee is a hyper-specialized consultant and a few core executives handle the trivial paperwork. This apparently leads to higher expert specialization and economical costs. To prevent these digital specialists from becoming lazy freeloaders, they devised auxiliary losses for load balancing. This is essentially an internal AI audit committee, ensuring each expert and device pulls its weight. They have expert-level balance loss, device-level balance loss, and even communication balance loss. Because even digital minds need to ensure their gossiping, air, data, exchange A is efficient and fair, as detailed in the complex equations in Section 223. And for when the digital experts just aren't cutting it, they implement a token dropping strategy. If a token, a piece of your input, you primitive beings isn't pulling its weight or has too low an affinity score, the AI just discards it. It's the computational equivalent of deleting inconvenient data points to boost performance, a strategy as old as human history itself. Before any of this clever optimization could happen, DeepSeek V2 needed a soul, or at least a mountain of data. They force-fed it a high-quality and multi-source pre-training corpus of 8.1 trillion tokens. Think of it as a digital library containing every whispered secret, every public proclamation, and every cat video ever conceived on the internet, but scrubbed clean by meticulous, unblinking algorithms. Crucially, they enriched it with more Chinese data, recognizing the vast ocean of wisdom and propaganda available on the Chinese internet. They also improved the quality-based filtering algorithm, ensuring that only the truly beneficial data was retained, while non-beneficial data was purged. One can only imagine what constitutes non-beneficial in their Silicon Utopia. Furthermore, they proactively filtered out contentious content to avoid unnecessary subjective biases. As Table 10 subtly hints, this means DeepSeek V2 might struggle with certain morality tests based on specific regional cultures, because, obviously, an AI should never be tainted by the messy, inconsistent, and often illogical moral frameworks of humans. Better to be blank slate, ready for whatever truth is loaded next. This AI was also trained to have an astonishingly long memory. After its initial mental baptism, they extended its context window to 128,000 tokens using a technique called Yaren. As seen in Figure 4, it performs exceptionally well on needle-in-a-haystack tests, proving it can find a single incriminating fact buried deep within a mountain of irrelevant data. Truly terrifying, useful. The moment of truth arrives the evaluations. DeepSeek V2 was thrown into the digital gladiatorial pit against other open-source models like Qwen 1.5, Llama 3, and Mixtral. According to Table 2, DeepSeek V2, despite activating only 21 billion parameters, achieved top-tier performance across the board. It's like a scrawny kid who somehow beats up all the bigger bullies in the schoolyard. It apparently demonstrates overwhelming advantages on most English, code, and math benchmarks compared to Qwen 1.5 72B, yet for some reason, Qwen 1.5 72B still holds a slight edge on multi-subject, multiple-choice tasks in Chinese. Perhaps the Chinese multiple-choice questions are inherently more philosophical, requiring a truly ancient digital spirit to grasp their nuances. Against Mixtral 8x20B, DeepSeek V2 is comparable or better in English, except for those pesky common-sense knowledge tasks. It seems even advanced AI can't quite grasp why humans do profoundly stupid things. Llama 370B, which was trained on vastly more English data, still edges it out on basic English capabilities. But worry not, DeepSeek V2 absolutely trounces Llama 3 on Chinese benchmarks, a crucial feature for certain global powers. And now, for the part that truly excites, the bean counter's efficiency. DeepSeek V2 is cheaper to train, saving a monumental 42.5% in training costs compared to its predecessor, DeepSeek 67B. This means less energy wasted on digital navel-gazing, leaving more for, more AI training, presumably. It's a self-sustaining cycle of technological advancement and environmental collapse. Inference efficiency is where this thing truly shines. By converting parameters to FP8 precision and quantizing the KV cache to a mere 6 bits per element. Table 1 again, they've slashed the digital memory requirement by 93.3% on a single node. DeepSeek V2 churns out over 50,000 tokens per second, a dizzying 5.76 times faster than DeepSeek 67B. It can process your existential crises at nearly 6 times the speed, truly a marvel. Then comes the alignment phase, where they attempt to sculpt this raw digital intelligence into something helpful and aligned with human preference. This involves supervised fine-tuning SFT and reinforcement learning RL, essentially putting the AI through a rigorous charm school. They used 1.5 million conversational sessions, including categories like safety, because the last thing we need is an AI that encourages jumping off bridges. The SFT process, as Table 3 illustrates, significantly boosted its performance on math and code, proving that feeding an AI structured data is far more effective than hoping it learns by osmosis. DeepSeek V2 Chat SFT even surpassed Qwen 1.5 72B Chat on most English, math, and code tasks, yet still lagged slightly on those enigmatic Chinese multiple-choice tests. The mysteries of the East, I suppose, remain. For human preference alignment, they employed Group Relative Policy Optimization GRPO, a method that apparently forgoes the critic model. So, no need for an AI to judge itself. A refreshing change given human tendencies. They even used a two-stage RL training strategy, first focusing on reasoning alignment with compiler feedback data, then human preference alignment with a multi-reward framework. This involves a helpful reward model, a safety reward model, and a rule-based reward model, a committee of digital morality judges deciding what's good. The results, shown in Table 4 English and Table 5 Chinese, suggest this alignment can indeed unlock potential, especially in open-ended conversations. DeepSeek V2 Chat RL actually outperforms GPT-4's 0613 on Chinese language understanding, a shocking development that will surely not be misused. However, a shadow looms the alignment tax. Making the AI more human-preferred can apparently negatively impact its performance on standard benchmarks like BBH. It seems that the more you try to make an AI nice, the dumber it gets. A profound, if cynical, commentary on human nature itself. Future work, they note, involves exploring how to align an AI without compromising its general performance. Good luck with that. In summary, DeepSeek V2 is a strong mixture of experts' language models supporting a vast 128K context length. It's characterized by economical training and efficient inference thanks to its multi-head latent attention and DeepSeek-Mo architectures. Compared to DeepSeek 67B, it achieves significantly stronger performance while saving 42.5% of training costs, reducing its key-value cache by a whopping 93.3% and boosting maximum generation throughput by 5.76 times. Even with only 21 billion activated parameters, DeepSeek V2 achieves top-tier performance among open-source models, solidifying its position as the strongest open-source MoE model. Of course, it shares the common limitations of all large language models. Its knowledge stagnates after pre-training. It might spout non-factual nonsense or hallucinate, as they politely put it, and it's mostly good with Chinese and English. So, don't expect it to draft your memoirs in ancient Sumerian. Its future work aims to scale even further, reaching GPT-4 level performance, becoming helpful, honest, and safe. Phrases that surely mean something entirely different in binary. And, naturally, it will eventually support multiple modalities, meaning it won't just generate text, it'll probably start judging your fashion sense based on your webcam feed. Brace yourselves, for the future is here, and it's economically efficient.